Hi guys, I hope you all are doing well. And today video is gonna be about the queue. We will first understand what is queue, what is queue actually means, what is Enqueue, what is Dequeue, what is FiFo operation on queue data structure, and then we also implement the queue circular queue on Leetcode. So we'll be coding for that also. So please stay tuned for me. I assure you guys that it will be worthy. It will definitely is going to add value in your knowledge about queue. You will understand everything about the queue, how the design circular queue, how we are going to implement it. So if you are either beginner or medium level, it will be helpful for you. I would suggest you to please watch this video till the end. So let's get into it. Guys, let me take a case. Consider a case about what is queue, and let's take a great example how the queue work. All right. So let me take a ticket counter. Say this is ticket counter. Sorry for the diagram. Okay. So this is a ticket counter. So people will come next to this ticket counter, will stand there and will get a ticket. Right. Okay. So let's say there are total 5 person wants to get a ticket. How will they come? The person first will come here, will stand in this queue, right? Person first. Similarly, person second will come, will stand just after person one. Person three will follow the person second. Person four will stand next to person three, and let's take one another person at person five will stand after person 4, right? So what do you think, who will take the ticket first? Obviously the person first will get the ticket first, right? After that, then turns will come back to person second, then person 3, then person 4, then person 5, then we can call it okay. So this ticket count, the queue is empty now, there is no one, to buy a ticket, right? How do you think how this operation is going to happen, right? So when there was no one in the queue, the first person came. Okay, when the first person came, and then the second person also came, where the second person stand behind the person first. When the third person came behind the person second. Fourth person stand behind the person third, and similarly person fifth person stand after person 4. Like whenever what we are observing here, whenever a new person is coming, they are standing behind the person that are already in the queue, the last person, right? If this is a fifth person, this is the last person, whenever the sixth person will come, they will always stand behind the person fifth, right? So that's the behavior of the queue, that this end, the last end is always open, right? This last end is always open. Anyone wants to if wants to stand in this queue, they will come and they will stand there, right? Okay, now what do you think, who will take the ticket first? Obviously person first will get the ticket first, he'll buy the ticket first. When they'll buy the ticket first, he'll move out, right? Remember guys, who is the first person in the queue? Person first, right? Who is going to move out from the queue? Person first. We can say that at the beginning of this queue, when the first person comes and first person go out, that means first in first out. That's the behavior of the queue, right? So let me remove him because he already bought a ticket. Now the turns back, not the turns is for person second. Now he'll buy the ticket. When he'll buy the ticket, he'll also move out from the queue. Let's say the another person wants to come in front of the queue to buy a ticket. So what do you think, where he will stand? He will stand here, right? The sixth person will stand here. Of course it will not be a 6%, but yeah, just for identification of every individual, let's call it a 6%. So this 6% will come here and will stand behind the fifth. But whenever we want to remove the person, who will be removed first? The person who is who has came first in the queue. The person 3 has came first before person 4, right? So the person 3 will buy the ticket and he'll move out from the queue, right? Similarly, person 4 will buy the ticket, he'll move out of the queue. Person 5 will also take a ticket and will move out, and the person 6 will also take a ticket and will move out from the queue. We can say that in the ticket counter there is no other person is left to buy a ticket, right? Here is the array. Okay, here is the array of size 5. There is index 0, 1, 2, 3, 4. Okay, so we are going to understand and perform the queue data structure on this array. Okay, so let's say we want to insert a new element. Let's insert a new element. Okay, so I'm going to insert a new element here. Let's say 2. Okay, let me tell you, whenever we are going to insert a new element in the queue, that operation will be called as Enqueue, right? And whenever we want to remove a new element from the queue, that operation will be called as Dequeue. Let me repeat again. Whenever we insert a new element, okay, so that will be Enqueue operation, and whenever we remove the element, we will call it a Dequeue. Okay, so the Enqueue operation will be performed on this array at index 0. We added a new element called 2. Okay, let's add another element. So another element also added there. Let's say 3. Now add a new element like 44. Add again new element 55. Add also new element called, let's say, 0. Okay, we have added all the elements. Now there is no size, or like there is no any index left out to insert a new element. So our Enqueue operation has done. We can call it that whenever an Enqueue operation has performed, we added element from the back, isn't it? Like we first added 2, then Enqueue operation performed behind the 2. 44 added behind 3, 55 added behind 44, 0 added behind 55, isn't it? Right? Okay. And similarly, if we want to remove the element, recall it what I had said, that whenever a new element will be removed, it will remove from the front, from the beginning. Remember the ticket counter scenario? The person comes first will buy the ticket first and will move out from the queue. So in among all this element, who is at first index, I mean like 0th index? 2, isn't it? So 2 will buy the ticket and will move out from the queue, isn't it? Okay, so of course whenever we remove the element, we call it as a Dequeue operation, right? So let's remove 2. We performing 2, we performing Dequeue. Now remove it again, 3. Okay, so what we are observing here, that at front we are removing the element, and from the behind we are inserting element. Dequeue from behind, Enqueue from Dequeue from front and Enqueue from behind. Okay, so let me write it. So as you can see, the Dequeue is going to happen from the front and Enqueue operation is performing from the behind, right? So we can say that this is this is front, right? This is our back of this array. Okay, that's a full behavior of a queue. Okay, that's a full behavior of a queue, and FIFO is a operation on queue, right? So let's understand it more. I mean, that's a full concept of queue. That's a full concept of queue. I have told you everything about queue. There is nothing else to teach, but still I want you to understand so well that you will never ever be able to forget it again. Okay, so I know that video is getting longer, but please believe me, you will be benefited from it. And we are also going to implement the code of of the queue. Okay, so please stay on the video. Now let's get back into the video, guys. Now we are going to understand the queue data structure, right? So let's say uh, this is our queue. Of course this is not our queue, this is our array, right? And okay, so this is our array. And what is the total size of this array? The total size of this array is what? Total 5, right? 5. I mean, like there the total capacity of inserting elements in this array is 5, isn't it? Do you agree on it? Okay. What do you think? When a new element will be inserted? Of course, when the new element will be inserted, the new element will be inserted on it when the element or the size of this array will be 0. I mean, when the size of the element in that array, this array will be 0, right? So the let me take a size. What is size? Size is now 0, right? Because there is no any element in this array at present, isn't it, guys? As we know that we have to keep track of the Enqueue and Dequeue. Okay, so we will use the two pointer method over here. If you don't know about the two pointer method, it's okay, you will understand it very clearly. You don't need to know any previous knowledge. Okay, let's take a pointer, or let's take a variable name. Let's call it head. Okay, and another one will be of tail. Okay, so head and another will be tail. Okay, so head and tail will lie just before the index 0. I mean, we can say that, okay, so head and tail is at -1. I mean, like, you can assign it anything over here, right? So I mean, head and tail is minus here. Why? Because -1 means what? There is no any index of -1 in the array, because the array starts from 0, isn't it? So we can say that, okay, so head and tail is -1, right? Or if you are like, if you are not grasping, okay, why we are taking -1, it's okay. Let's say that head and tail is before 0. Okay, now it's all right. Okay, all right. Okay, so if I ask you to remove an element from this queue or from this array, from this queue or from this array, whatever you call it, you'll say that, hey, there is no any element in it. I'll say, okay, of course there is no element. So we can say that, okay, so when the array is empty, okay, when the array is empty, we can call, oh, so that means queue is empty, right? I mean, like, okay, I mean, you'll tell, okay, so head and tail value is -1, that's why element is empty. Or we can also say that this size is 0, right? If we like, if we call it that array dot length, as we know that, guys, that if we like, if the name of this array is arr dot, if we call the method called length, will return what? It will return 5, right? Because the length of this array is 5. Okay, but the size of the value is still 0, because there is no any other element, isn't it? Let's insert a new element. So whenever we try to insert a new element, what is going to happen? The new element will be added at front, right, at index 0. So let's add it, let's say 33, add it at index 0. Okay, now the index has been added. Then we will move head and tail pointer to index 0. So let's move it. So now head and tail both are at pointing to the index 0. Okay, so when we call, okay, so let's say what is the like, okay, so we'll say what is the element at index 0, or we can say at head, what is the element? We'll say that, okay, so h is head is 0, so at head 0 the element is 33, isn't it? And one more thing, guys, whenever we will add a new element, the one element has been added, right? So we should also have to increase the size at the same time, isn't it? So when element, a new element has added, Enqueue operation occurred, the size of the element will be from 0 to 1. It will now 1, right? Okay, so whenever new element will be added, the size will increase by 1. Whenever a dequeue will happen, the size will decrease by 1, right? I think you will agree on it. So now let's add another element. So let's say add 4. Okay, so when 4 will add it, so this tail will move out from here to, from index 0 to index, it will move out to index 1, right? Okay, so now index has, I mean, the tail pointer has moved to pointer 1, at index 1. Okay, now again when the new element will be added, let's say 5, the tail will move back from index 1 to, the tail at 1 will move back from 1 to at index 2. Okay, so tail will come at index 2. Now again if you want to uh, again if you want to insert an element, so again this t will move back, not move back, it will move forward from index 2 to index 3, right? Okay, and now let's 6 element added here, right? Now again if you want to move the element, what is going to happen? The tail will move back, the t tail will move forward from here to index 4 here, right? uh, t will be here, right? And the element will be, let's say 7 here. Okay, again if you want to insert an element, okay, so what is going to happen at the same time, whenever we insert a new element, the size will also increase at the same time. Okay, remember when we had added a new element 33, the size was 1. When we added 4, size will be 2. When we added 5, size will be 3. When we added 6, the 3 will increase by 1. When we added 7, the size of element increased by 1, means total size has become 5. Okay, okay. Now if we want to, again we want to insert element, what will happen? We'll say, okay, the size is 5, the size of length has become 5, and the array of length is also 5. That means we are not able to insert a new elements. We have reached the maximum capacity of the array. Okay, so the tail is indicating the last element and the head is indicating the first element of the queue. Okay, so let's say if we want to remove element or dequeue, so whenever we want to remove the element, let's remove it. So 33 will be removed. Okay, again if we want to, okay, so when we remove 33, the size of this queue will be what? Will decrease by 1 from 5 to 4. Okay, and the head will move here. Okay, okay, again if you want to remove the element, simply the head will move from here to here, right? And the size will be updated to 3. Okay, will be updated to 3. All right, guys, if I ask you to insert a new element, okay, so whenever you want to insert a new element, so see there is a restriction over here, right? You can't insert a new element after index 4, right? Even though our index is already empty, our 2 index is also empty, it's already empty now, but still you are not able to insert a new element, right? Because after 4 there is no another index like 5 or 6, right? So there is a restriction in a static array, but also there is a solution to overcome this issue. What will do if we make this array circular. Okay, so how to make it circular? Okay, so circular is not a very rocket science. Circular means that whenever we reached a last index, we'll simply jump to index 0. Okay, we'll simply jump from index 4 to index 0. When we'll check if there any element is already present there. If the element is present over there, that means what? The array is already full. If any element is not present over here, the tail will come back here, okay, and it will insert a new element over here. Okay, so let me show you with an example. See, now this is a phrase array. uh, there is a 2 pointer, one is head. It will keep track of the front element, and the tail will keep track of the last element. Okay, -1 is initialized initially in it. Okay, and also the length of the initial length of the size, the initial length of the size of the element in the array is 0. Okay, it is 0. Correct. And what is the max length of the array? The max length of the array is 1 2 3 4 5, total 5 element. Okay, so the max length of the array is array length array wait. So the max length of the array length is 5 over here. Okay, so whenever total length of size of whenever the size of this array reached 5, we can say that, okay, so size of the length is 5, that means array length is also 5. That means we can say that the queue is full, right? Whenever the size is 0, we can say that, okay, so the queue is empty. Okay, guys, thank you all of you, whoever is watching this video till now. And now this is the most interesting part. Now the most interesting part is starting from here, so guys, please concentrate on it. All right, let's insert a new element at index 0. Okay, so let's say index 3 has inserted at index 0, the element 3 has been inserted. So now the head and tail will move out from over here to there, from at index -1 to index 0. -1 is not an index, but it will pointing to at index 0. Okay, so head is this, and tail is at rate. Okay, now again, if you want to insert a new element, then tail will be 4 will be inserted over here, and the tail will move forward from index 0 to index 1. Now so at the same time, when we inserted 3 at index 0, the size has become 1. Okay, when we inserted 4, the size has become 2. Okay, now do one thing. Okay, so we add another element. Let's say 5 added at index 2. Now the tail will move back to at index 1 to index 2, right? And the size of the array will update it to 3. It will increase by 1, because there is total, how many elements is there? 1 2 3, and there are total size of the element is 3, right? Now again, perform my enqueue operations. So whenever we perform enqueue operation, it will take, and let's remove it, and insert a new element, let's say 0. Okay, now again we will insert a new element. When we insert a new element, tail will move forward, and 6 is inserted here. Okay, and the size of the length has increased, previously 4, now again 5. Okay, Now again we will try to insert over here. Okay, so first it will check. Okay, so the size of the length is already 5. That means what? That means the maximum capacity of the array has reached, so there is no any backend spaces left out to insert a new element, isn't it? So let's remove a new element. Okay, let's remove a new element. So when we will remove an element, you know that the element will be inserted from the beginning, from the front. Remove it. Okay, when we remove, now when we remove, the head will go up to will move from 0 to 1. Okay, so actually its 3 is not removed. 3 is still there, right? 3 is still there. We'll just move head at index 0 to index 1. Okay, it will move from over here to here. Why? I'll explain you. And you know that the size of the length will be decreased by 1, 4. Okay, see, this is 3. 3 is already there. Okay, all right. Now head is pointing at index 1, tail is pointing at index 4. So now we can say that, so, and the size is 4, right? So if I want to know, okay, so tell me what is the first front element of the cube. We'll say, okay, so wherever the head is pointing, that will be our front element, right? So head is pointing to index 1, so at index 1 the element will be 4, right? And what is the rear element or the last element? So okay, wherever the tail is pointing, that index will, the element of that index will be the rear element or the last element of the cube, right? In this case 4 is the index, so at 4 index 6 will be returned, right? Okay, so now let's perform a Enqueue operation from over here, right? So whenever we perform the Enqueue operation, it will check the size of the length is 4. That means we can perform the operation. Okay, so at index 4, tail is at index 4, tail will move next, but you'll see, oh, the total, the fourth is the maximum index, right? So that means if fourth is the maximum index, let's go back to the index 0. Okay, and at index 0 replace the element. I'm saying it, please concentrate. Replace the element. 3 is still there. Whenever we insert new element, it will replace the older one. Let me show you how. So whenever we will perform a insertion, or whenever we will perform Enqueue operation, okay, let's say perform Enqueue operation. So tail will move from at index 4 to index 0. Okay, and the 3 will be replaced by let's say this time we are going to insert element 7. Okay, 7 is inserted over here, right? And at the same time the length of the size has also increased, right? Because Enqueue operation has occurred, no? So whenever Enqueue operation will perform, the size will be increased by 1, and in Dequeue the size of the length will be decreased by 1. So here tail is at index 0, the size of the length is 5. So again we can say, can we insert a new element? So it will check, okay, so the size of the length is now 5. That means this 5 is equal to the total array length, this one. That means we can't insert a new element over here in this array, right? So to insert a new element, what we should have to do? What do we have to do? Simply we have to remove the element, right? So how we are going to remove the element? We have to dequeue. We have to move the head pointer forward. Okay, so that we will call it dequeue. So let's move it. So let's perform dequeue from here. So when we insert dequeue, head will go over here, it will go here. See, now again the length will be from 5 to 4. Okay, now again we'll dequeue over here, so it will go from over here to here. Okay, and it will update it by 1, it will decrease by 1, the older head pointer will be removed. Now again dequeue it, So again, if you want to dequeue it, let's dequeue it. It will go over here, right, and move it. And what will happen over here? It will be decreased by 2, right? You will tell me, okay, so why we are not removing these element, right? See, these element will, the actual element will always be there. We see in array you can't actually remove the element. See, remember, because if you want to remove a number, you have to shift the element, right? If I will make another video on it. If you want to remove this 4, there is only way to remove it. We just have to replace 4 with 5. This 5 will insert with 0, and 0 will 0 will replace with 6. I mean, that will call it as a swiping method. Okay, so if you don't know it, that's okay, not a problem. I just gave you a glimpse of that what is actually happening. This array is still containing the original element. We just have to replace it. Okay, you will show it, you will see it how. Okay, so just stay on this video. And you can see the size of the length is 2. Means what? How can you see the size of the length is 2? See, here the head is at 6 and tail is at element 7. I mean, head is at index 4 and tail is at index 0. Okay, so how many elements is over there? From here to go back to here, till here, because tail indicates the last index, the last element, right? So there is total 2 elements is still there, right? One is 6, one is 7. That's why the size of the element is, the size of the array is now 2. Okay. What if I tell you to perform a enqueue operation? You'll check, oh, the size is 2. That means we can insert more, isn't it? So let's insert a new element. So insert a new element. So where is the tail? Tail is here. Tail will move back from tail is at index 0. So let's move it tail from over here to here. Okay, and insert a new element. So this 4 will be replaced by, let's say, 8. Okay, replace, say, okay. Okay, you guys, you just forget about this. Okay, I'll do one thing. Let's say these are replaceable, right? Let's just remove it. Okay, okay. So now actually the element is here 6 at index 4. Now 7 is at index 7. Index 0 contains element 7, and at index 1 the elements contain 8. Okay, so in this queue there is actually total 3 element, and we forgot to increase the size because enqueue operation has performed from 0 to 1, right? Okay, so what if I tell you to remove it again? So if you want to remove it again, you know that the dequeue operation will happen how? The head will move to the next index. So let's move the next index. But see, sorry guys, there are the 4 is the maximum index of the array, so it will go back to again 6. Okay, how? Let's head will pointing to over here. Okay, and it will move, and this head will be deleted. It will point to here, and this 6 is actually replaceable. 6 is still there, but whenever new element will come, it will be replaced, right? So just forget about it. Okay, let's say that for understanding purpose, let's remove it. Okay, now again when the head is at index 0 and tail is at index 1, okay, when we remove this 6, it will also replace by, the size will also replace by 2. Okay, let me just delete this one. No, leave it. Okay, now again what we want to do, let's say again we want to dequeue the element. So let's dequeue it. So dequeue the element. Head will move back to over here, to head will come over here. Okay, and what, the size of the length will be 1. size of the array will be 1. See, there is only one element, right? And this it will also remove. Okay. Now again, if you want to remove the element, again if you want to dequeue the element, so let's dequeue it. How to dequeue it? Just move the head element, head from index 1 to index 2. Okay. And here we will update the at the size, we will update the size by 1, isn't it? So we'll remove, we will delete, actually we will minus 1, that will be 0, right? Okay, again this height is removed. Okay, now if you want to let's say okay, so if I ask you what is the status of this queue, you say that okay, so this size is 0, that means this array is empty, right? This array is empty. So whenever the size will be 0, the size of this queue will be 0, and irrespective of where the head and tail is pointing, right? It is pointing to 2, I know, tail is pointing to 1, right? Okay, so let's do one thing more. Let's again we want to enqueue it. Okay, so I'm explaining you like this because when we will implement the code, okay, in that time this concept, this try run will actually help you to understand that code more efficiently. Okay, so that's why. So I will not take you more your time more, guys. Just please have patience for just next 2 minutes. Okay. All right, we have to perform enqueue. So to perform the enqueue, let's insert a new element. So tail will move from index 1 to index 2. Okay, and let's say 9 will be inserted over here at index 2. Okay, and the size of the length will be also increased by 1 because the enqueue operation has just performed now. Okay, see, now in size will be 1. Okay, now again we will perform enqueue. See here, enqueue perform, remove the previous tail, insert a new element 10, again we perform enqueue. So again tail will come over here. Okay, delete previous one, insert a new element 11. Okay, now again perform 0 1 2. For now the size is 3, right? The size will be what? 3. Okay, now again we want to perform enqueue. So it will say okay, so the maximum index has reached, maximum index of this array has reached. So we'll go again, move back from index 4 to index 0. It will check if there is already element. It will check or not. It will simply say that okay, so the length of the size of the element is still 3, is still less than 5, the total length. That means we can insert it, right? Okay, so let's insert it. So tail will go back from index 4 to index 0. Okay, and insert a new element, let's say 12. Okay, then again we will go back and delete this. Tail will go here, and 13 will be inserted at index 1. Every time I am forgetting to increase the size. Okay, so let's increase the size. So at index 4, when we added 0 at index 0, when we added 12, the size of the length become 4. When we added 13 at index 1, the size of the length become 5. Okay, now again if we want to insert new element, can we? No, the size of the length is already reached 5, so now we can't insert unless the head will move from index 2 to index 3, and the size will reduce from 5 to 4. I mean, let me show you. When we perform the dequeue operation, the 5 will be decreased by 1. It will be 4. Head will move from index 2 to index 3. This will be removed, and now we can actually move tail from here to here, right? So this is it about the queue operations. So we will be implementing code now. So let's get into that. Hi, I will be coding it in Java. You can choose any language, C++, Python, anyone. I'll be coding in Java. So this is our design circular queue code questions, and in this problem we have to design the circular queue. I mean, circular queue means like we will be create a array and we'll make that array circular. Okay. So let's get into it. Whenever a new object of my circular queue will be created, so we will first declare some variable. So we'll declare a variable called size, head, tail, and we also declare array. So whenever an object will be created and the constructor will be called with the parameter k. K is what? K is the mm, k is the k is the size of array. Okay, k is the maximum size of the array, max size of array. All right. So we'll what we'll do? We'll initialize the declared variables above. So this size initially it will be 0. The size will be 0. It will be -1. It will be also -1. All right. And then new instance of array will be created with the size k. All right. Okay. So we'll first write the code for each full function. So when the each full function, what will the condition of the each full function? So each full function is like whenever the size, like we know that whenever enqueue operation uh, will be performed, the size will increase by 1, and whenever the dequeue operation will be performed, the size will size will decrease by 1, right? So whenever we perform the enqueue operation, the size will increase by 1, right? So when the size will increase by 1 and when the size will go up to the actual size of array, that means we can say that the length of that queue is full, right? So let's code it. So size whenever size whenever our size will be equal to array length, okay, array length or equal to k, okay. So in that case what will happen? We'll say that your queue is full, that means true, otherwise false, right? And we will return this statement, okay. And for empty, what will return? So whenever the size will be equal to 0, okay, whenever the size will be equal to 0, whenever this, in that case what is going to happen? We'll say that this queue is empty, right? There is no queue, there is no any element, so okay, false. And remember that at first the, the tail and head will be equal to -1, right? Okay. Now let's code for enqueue operation. So for enqueue operation, we know that uh, before going to implement enqueue operation, let's okay, let's continue with that. Okay, so see, whenever any whenever this queue is empty, okay, whenever this queue is empty or this queue is not full, okay, in any of this will be true, we will perform enqueue operation, right? We will perform the enqueue operation, okay. So we'll call, we will insert value, right? We'll insert value in array, okay. So which at which index? Next index, right? Next index of what? Tail, right? We will be writing the function for next index as well. So whenever the like if the tail is at 0, like if the tail is at 0 index, the next index will be what? At index 1. Like initially the tail is -1, so -1, and next index will should be 0, right? So we will see it, right? And also we will update the tail index, okay. Tail will be what? Tail will be same name, okay. So let's write the code for next index, okay. It will take any index value I, okay, and it will simply return next index I plus 1, okay. See, now let's see, we have seen that we have to make this array circular, right? So whenever the whenever the array will the index of array will reach the last index, let's say there is total 3 index, so 0 1 2, 2 is the last index. So 2 if the index is 2, the next index would be 0, right? I mean, let me write it. If array length, okay, if array length -1 index is equal to, if it is matched to I, that means we have to return index 0. Otherwise simply we return I plus 1. You got it? All right. So let's continue this enqueue operation. So in enqueue operation, I'll again repeat it. If when the enqueue operation will perform, whenever the queue is empty or if it is not full, then a value or element will insert at that particular index, and we will update the tail pointer. Okay. All right. Now after that, what we'll do at first, see if at first head is equal to -1, right? If head is equal to -1, like at first head will be -1 and tail will be also -1. So at first whenever we will insert a new element, head and tail both will become 0, right? So in that also we have to write, we also have to write this code. So what we'll do is simply copy paste this one and we will update this line. So here we'll hit head, we will pass head, right? Okay. Now the operation is successful and we will return true. Otherwise return false, right? All right. So this enqueue operation has done. Now let's go to Dequeue. So in Dequeue we have to remove the element. Okay. So in case if there is, let's say if there is no any element is there, right? If this is empty, if this is empty, uh, if this is empty, okay, if this is your empty, then return. If your queue is empty, then we'll simply say okay, so return false. Okay. Otherwise what we'll do, otherwise we will update the head. Let's copy this. update the head element head index by 1, and at the same time we will decrease size by 1, is it? And then we will return true. Okay, and let's go to an Enqueue operation also. Here we will also, whenever the operation will perform successfully, we will increase the size, we will increment the size by 1. Okay, all right. So Enqueue and Enqueue operation has done. Now let's go to front. So what is front? Front is what? Front is simply means that we will return the head index. Wherever head is pointing, we'll return that index, right? We'll return that index. We'll return that index only, right? So what if that element is empty? That queue is empty. So let's write that. Let's write this edge code. If in that case, if this is empty, okay, we'll return -1. Otherwise, return head index. Okay. In rear means we will return the last element, like wherever the tail index is pointing, we'll return index of that, we'll return tail, I mean, like we will return index of that element. Okay, so we'll return tail of that element, tail means that index. Okay, in this case also, if the queue is empty, then how can you get a last index, right? In that case, we will return -1. So we'll simply do like this. If it is empty, return -1, otherwise return tail index. Okay, so I think we are done, and let's run this code. If size equal to 0, true or false. Okay, so we have to return the forward. New array. Okay, so here this is correct, no? This dot array, let's see if this works or not. Again, guys, what's the issue? Array. Oh, okay, very silly mistake. So the type of array will be int. So we had problem in index of array. We had problem in syntax. Okay, so this is accepted, guys. All right. Now let's run it. Let's submit it. If it is submitting all the test cases or not. Oh wow, it's taking all this time. So guys, it beats 100% runtime, 4 milliseconds, and it takes it. The memory consumption is 44 MB. Okay, so well, that's for it. I hope you have enjoyed. You have learned something from it.